Okay, everybody. Yeah, this is hello. This is the track TC3, A Brief History of Sound on Mars. And the speaker presenter is Jason Mezilis.
Yeah.
Yep. And yeah, Jason, whenever you're ready, you can get started. And then if anybody here has questions, you can type it in the chat and I'll read them at the end of the presentation.
Okay, cool. Yeah. So let's see here. Should I? Oh, there. I've got on grid mode, so everybody's popping up here real quick. Thank you all for joining us. Let's see. So should I go to the share screen part then, I guess?
Oh, yes.
Okay. All right. Thank you all for your patience while we figure this out. Okay. Is this good? Can is it everything
yes,
looks
I
good?
can see it.
All right, everybody. Thanks for joining us. I hope everyone's enjoying the conference so far. My name is Jason Achilles Mezilis, long Greek name, and I'm here to present This is a presentation I used to give a few years. I started doing this a few years ago, called "A Brief History of Sound on Mars." But I wanted to sort of give you all a sort of special updated version of this. Because since the last time I had this discussion, we've now actually had sound on Mars, and this was something I've been very fortunate to be a part of, and I wanted to sort of take everybody through a fun personal journey, as well as sort of the history of how this came about. And I'll just preface this by saying a lot of this information is, publicly available online. I've definitely condensed and simplified things for ease of presentation here, and but you can find a lot of information about this development on the NASA website. I think you go mars.nasa.gov/multimedia, and there's a lot of sound samples there that have been collected over the last few months, or 6 months, I guess. Also, the Planetary Society on their website has a lot to say about this, and we'll discuss that a little bit. So and I guess the only other thing I'll preface this by is I put these slides together pretty quickly. I'm not sure what order they're in, so I might jump around a little bit, but we'll try and make this cohesive. So any good discussion about Mars and scientific exploration, you can't really go wrong without... oh, well, actually, okay, I forgot about this. This was actually a really funny cartoon that came out I think it was like right around the week when Perseverance it was right before Perseverance landed. And I had a lot of friends of mine calling me up asking if this was actually about me, because I'm actually a musician by trade. And I was working on one of these microphones. This had nothing to do with me. I'm pretty sure the creator of XKCD does not know I exist, but nevertheless, it's a very fun cartoon. And anyway, that's XKCD if anybody's looking for it. So Carl Sagan, it all goes back to Carl Sagan, as with all good things in the scientific discovery world. Shortly before Carl Sagan passed away in 1996, he had made a audio recording that was this beautiful poetic sort of message to the future explorers of Mars. It was an audio recording with a waterfall in the background. It wasn't recorded in a nice acoustic environment, but it is a beautiful recording that you can search for online. I'm not going to attempt to play any audio during this because I don't want to risk audio or video during a Zoom playback, but it's easy to find. Just Carl Sagan Message to Mars on YouTube. I really highly recommend you check that out. But that same year, he wrote a letter to NASA, and this was what he wrote, or at least part of what he wrote. He said, even if only a few minutes of Martian sounds are recorded from this first experiment, the public interest will be high and the opportunity for scientific exploration real. And basically, he was a proponent of an idea that, the name of the individual who first came up with that actually escapes me, but Dr. Sagan latched onto this and was really supportive of this idea. This was actually one of the last things he was pushing for before he passed away. And then following this, the Planetary Society, who obviously Carl Sagan was one of the founders of the Planetary Society, so they supported a program that I believe it cost about $50,000 or so, and they were able to And this is a little tricky. And it was, I think they were working on a Russian, in pairing with a Russian instrument that was going to go on Polar Lander. But in 1999, they were able to put together a microphone that that went on the Mars Polar Lander. And for those of you that know your Mars landing craft, Mars Polar Lander did not fare so well. Unfortunately, it landed more rapidly than expected. And so no audio was ever retrieved from that mission. I mean, well, nothing was retrieved from that mission. But I guess what I was surprised to find, and maybe some of you are as well, is that this audio has been, people have been trying to capture this for over 2 decades. So the first attempt was made with the launch of Polar Lander in 1999. The next actual launch of a microphone, there was another attempt made in between that time, but that mission never got fully funded. It was, I believe it's called Netlander, I think. Again, this was, I can, this is, if the Planetary Society actually has a very good review of this history on their website. But in 2008, Phoenix Lander was sent to Mars, and that landed successfully, and had a microphone on board. However, the microphone was actually never turned on, and this was an interesting point because this is actually informed future microphone design, as I understand it. And I spoken with a few different people involved in that mission, but it sounded like the clearest summation was that it was essentially hardwired directly into the main computer in such a way that operating the microphone might cause, there was a small chance of serious problems, associated with turning the microphone on and how that might affect the main computer, such that it was determined that that was not a risk anybody wanted to take. So that was basically, that was turned on, that was put on the rover, but never actually turned on, which is kind of a bummer. But so we continue on to, so Mars Curiosity just didn't have a microphone. I don't know that it was ever even really considered. I know that a lot of proposals online were sort of seeking to justify the scientific validity of a microphone, which is something we're going to get to towards the end of this discussion today. But it's a bit of a hard case to make because even with video, which, is astounding and beautiful. I mean, even as recently as the Juno mission to Jupiter, there was not initially going to be, at least my understanding is there was not initially going to be just a regular camera on that thing. And then somebody was like, well, where's the camera? Well, what are you talking about? Well, what are you talking about? So sometimes, these things that we feel are obvious, especially to, regular people like, myself and others, like, why wouldn't you want to hear the sounds of Mars? But, NASA missions have to put scientific priorities first, and other concerns come secondary or sort of piggybacked. You might find good reasons for outreach that are piggybacked off of scientific instruments. Well, Perseverance comes along, and scientists decided they wanted to put a microphone on this thing. They actually ended up putting 2 microphones on this thing. And I'm going to give you a quick review of those right now. The first one was, let's see here. So you'll see there's 2 little blue circles on our nice picture of Perseverance here, which of course used to be called Mars 2020. The first is this guy. That is where the SuperCam microphone is located. And that is part of the SuperCam instrument, which now what you're looking at here is, let's see, if we go back, you can see the shape of the kind of, head on the mast there. And this is a close-up of that head. And where that little red box zooms in, you see on the bottom left, and then zooms in again, you see the bottom right. That's a quarter there for size comparison. At the end of that little tube, which is, pinky sized, I'd say, is an electret microphone. And that is not the system I worked on. So I can't speak too much in detail about it, but that was put together with cooperation from the French Space Agency. And that was actually, was included as a scientific instrument. So there's actually a lot you can read online about this, but essentially there's a laser as part of the SuperCam instrument. And what it does is it can hit rocks from a distance, and as it hits the rock, you'll see a quick, there's an audible crack sound, and depending on what they heard compared to what they expected to hear, the idea is that that sound will help inform diagnostics, analytical diagnostics about the, I'm not sure if it's the chemical composition of the rock or perhaps the physical composition in terms of like maybe how much air is inside when it releases. But there's scientific determinations that can be supported by hearing this audio. They also did a test because the zap, as you will, is instantaneous enough that they could verify the speed of sound on Mars, which was suggested to be about 2/3 of the speed of sound on Earth. And so that was validated through this experiment. And you can hear these sounds on the Mars website if you go to that multimedia link. So that's the SuperCam mic. Again, that's not the one I was involved in. Now we get to the EDL cam microphone, the entry, descent, and landing camera system microphone. That's a lot of words. So basically, what happened is, I imagine everybody here is very familiar with the sky crane maneuver that landed Curiosity and then Perseverance. And there was a lot of cameras attached to this system. As it turned out, none of these cameras had any audio component. A lot of cameras, like your GoPro type cameras, have microphones included. But these particular cameras that they attached, which hopefully you've all seen this footage, which was incredible, didn't have any audio component. And the Dave Gruhl, who was the Atlo manager for Perseverance and later became my supervisor for this program, he very much wanted to have this audio component on board, as well as a few other folks involved. And so I guess my personal story briefly is that I reached out to NASA around this time, and I come from an audio engineering background. And as a space enthusiast, like many other people here watching, was basically able to get a consultancy position on this. So basically, I assembled an engineering team to help initially help design what this microphone system would be, and then ultimately, due to cost issues and a couple of other concerns, basically there was no extra money for this microphone. So this really was a passion project of Dave Gruhl and a few others that really wanted this to work. And so ultimately we ended up flying an off-the-shelf component, which I'll show you shortly. And so that was what my team helped. We helped evaluation studies, testing, and then ultimately helping select the flight hardware that flew. So just to give you a little more detail on this mic, this is a little rendering. This was I had put this together before Perseverance landed. So, but if you zoom in here, this on the, I guess so. If you think of this as a car, this is roughly where the passenger door handle, driver's side door handle would be. Maybe a little bit behind that, there's this sort of metallic structure with all kinds of hoses going and so forth. And right at the top of that, where the little black circle is, that's our microphone. So here's another, this is actual photograph of it, but I wanted to show you the rendering first, because this is a little complicated to see. But this is an actual photograph of that same microphone mounted on the rover. And you can see the RTG in the back on the right-hand side. And so this is, again, facing forward, is facing to the left of your image of your screen. And coming out of the back of that, diligently wrapped and capped on tape is the cabling that goes inside. And so microphones are generally, there's a diaphragm component, which you can see sort of, it's that gold part with the little grill sticking out there. And then there's a preamplification system, and we were able to find a system, and let's see, let me get forward. Yeah, here we go. So that, if you look back, so that this on the top left here, this is the actual microphone capsule. That's about the size of your thumb, just this part of your thumb, the first joint. If I can, there's your thumb. That's a 1/2-inch diaphragm omnidirectional capsule. This is a high quality recording studio microphone. It's what they call a measurement microphone. So it's got a very flat equalization response curve, and the idea behind that is that you just get as true an audio representation as possible. And if I go back again, you can sort of see that gold, capsule there. That's that guy. And then on the bottom here is the preamp section, which is about a little bigger than a silver, like a $50. That was housed internally. So basically, there's obviously a lot of environmental concerns on Mars. So you don't want anything sticking out that you don't need. So the capsule obviously has to be external because you're measuring external sounds. But the preamp, which is where you have your analog to digital conversion of the signal to then feed into the main computer, that can be housed internally. So this was actually a new product that came out right when we were doing this study. This was something Dave actually discovered and forwarded to our team. So he did an analysis of this and agreed that this was the best way to go. And so that's what was flown. And as sort of a kind of a neat, I don't know if you can see this, but I'm actually talking to, so people are, okay, how does this sound, right? It should sound good. I'm actually talking to you right now. I don't know if you can see this. Maybe I can move it. The microphone I'm talking to you right now is a flight model of the microphone that flew. So this actually has the same customized flanges on it that were put here by JPL to help mount the capsule. And I'm not sure if the cable is long enough or not, but this is the preamp. So comparison, that's my hand. So this was housed internally. And what they ended up doing actually was taking the guts out of this, cracking the shell open, and then rehousing it. JPL rehoused this in their own, like internally near the computer that this was interfacing with. So I don't know. I know it's a little small there, but there you go. So yeah, it's a great sounding mic. I've actually since used this for some recording work. It's very high quality. Let's see here. So as far as a bit of preliminary testing and so forth that we engaged with, there's a few things here. That initially this microphone and one other, we whittled them down to the final, shootout of what components we were going to use. This is a vacuum chamber at JPL in which the final two contenders were put into. That speaker on the little white thing there is a speaker from like something you put in a boat or something like that. And this chamber is closed up, lowered to Mars pressure and atmospheric conditions. I don't think it was temperature. I think they kept it. I don't think they worried about temperature. But anyway, microphones worked inside there, and so they figured, all right, good enough. This is a study this this looks a little janky, but this is actually a very effective experiment where one of my engineers and I went in his backyard in Reseda. We took some sheet metal plates, one of which was that parking sign we found in the alley, but it functioned well, and a metal plate. And this setup was to perfectly, or as close as possible, mimic the physical mounting conditions of that microphone, because sound reverberates off of all structures, and metal is a particularly bad one. And so we were trying to characterize if we caught any loud signals, how they might be altered by the reverberation on these physical structures. And we came up with, this was a corrective equalization pattern that we were able to come up with based on a comparative analysis running different, white noise, pink noise, different tones, sweet tones through that cycle, and then comparing them to an unmounted capsule. And this is a Fab Filter is the program we used for this. It's a very high quality, newer program for structuring these kind of analyses. And then this was a dust mitigation attempt by myself. This is a sketch. This did not end up getting implemented, but something far similar than this, where basically an extra layer of dust protection was put as like an added filter. That was kind of the only main customization of the capsule. Everything else was basically something you can buy all this stuff. I mean, it's expensive, but you can buy this stuff. So it worked. It recorded the audio, and the EDL, as some of you may have noticed when you watched those cameras descending, no audio was connected with that. Well, why not? Well, the short version is that there was a problem between the onboard computer and the digitizer, and during the initial descent, the actual entry, descent, and landing, both all these machines were turned on, but due to just sort of an unknown issue that happens from time to time, these computers did not engage and did not talk to each other, and so the microphone did work, it did function, but what was actually captured in the computer was basically 5 minutes of binary garbage, and so unfortunately, that whole entry sequence was lost, and we did not capture that audio. However, on Sol 2, Dave Gruhl had the microphone turned on again just to see if maybe they could catch something before the big press conference they had that following Monday. And that event, the microphone did work. It turned out the capsule was fine. And so during that press conference, that's when the world first heard the sounds of Mars, which was a very little gust of wind, but it was a beautiful gust. And so that was this microphone. And then more sounds were later shared. And but we were fortunate to be able to, again, share with the world those first sounds of Mars that everybody actually had a chance to hear. And, I would lie if I said it wasn't an emotional experience. So I'm going to get to this. I know we got questions. I'm going to wrap this up real quick. So, okay, sound on Mars. Why should we care? And this is now what I'm working on. For the future of Mars explorers, human Mars explorers especially, is introducing audio and an audio component into EVA suits for our boots on the ground humans on Mars in the future. And this is just a quick rendering that we did up a while ago with my company. I mean, this can all change, but this is based on proven the proven technology that has flown and works. And this is sort of you have to think. So a lot of people don't understand the value of audio in their life until it's removed, and I guess the best thing I could say is if you put earplugs in and just walk around and, have one day of your life not being able to hear much of anything, you'll rapidly understand why audio is important. You can do tasks faster when you can hear what you're doing. Let's say you're driving your car, you're operating a machine. If you're doing construction, a lot of times your first indication of problems with your mechanical systems is something you'll hear. So diagnostics can be improved. If you're walking, if you can hear the sound of your footsteps, or if you can hear if there's loose dirt before you lose your footing, this is a way in which your mobility is enhanced through sonic awareness. And safety is a similar concern. I don't think there's too many, Martian bats that are going to be attacking anybody, but someday we're going to be exploring caves, and we're going to be exploring Titan systems with, physical issues that might arise. And so hearing and auditory awareness is going to be very important, and also mental health. And this is actually, I think, maybe the most important and hardest to comprehend, but I think this is a really important issue, is that, when you're on Mars and you're in your bubble and you want to get out of there and you want to go for a walk and experience your environment, you can't breathe the air, you can't smell the air. You're going to be very limited in your actual physical awareness of the planet. But one thing that this system can provide is sounds. You can hear yourself walking. You can hear reverberance if you're in any sort of cave-like structure. You can hear just wind creeping over. I think it's really going to help people from going nuts. And so I'll just end this talk by saying what I like to end by saying, this fella might not be able to taste that beer, but he'll definitely hear it crack open. And with that, I guess we only have a few minutes left for questions, but I'm happy to take them. So I'll kill the slides here, and if I can figure out how to kill the slides here. Boom, okay. There we go.
Cool. Yeah, so the first question we have here is, as we receive more sound samples from Mars, do you think that we can recreate or simulate Martian sounds in analog missions on Earth?
Can we simulate Mars sounds on Earth? Is that the question?
Oh, yes.
Well, I guess part of the question would be, why necessarily would you want to? Because it doesn't sound as good there as it does here. To that effect, though, I will say one sort of interesting. So at one point during working on this mission, I don't know if anybody here saw the movie Ad Astra, but there's a very brief landing sequence where a rocket lands on Mars, and it's an external view. And I was actually asked to help them work out the sounds of that. So it was kind of a reverse engineering of the question you just asked, where basically, due to our research of sound on Mars, here on Earth, we were asked to recreate the sounds of Mars for a movie about Mars on Earth. And if you watch that movie, there's that brief landing sequence, and I think they actually got it pretty close. So I guess that's kind of an answer. I'm not sure if that is quite what you're looking for, but there you go.
Okay. Another question is, Martian atmosphere is really dusty. So how would you prevent the microphone from being affected from the dust?
Yeah, it is very dusty. And, we weirdly enough didn't seem to have any real problems with it. Now, so my contract with JPL ended pretty much the day, like a few days after the landing. So I'm not privy to I'm not sure what condition it's in now, because it's been a while. And unfortunately, the microphone that we flew has sort of become what they call an orphaned instrument, meaning that there's not necessarily anybody really in charge of it anymore. It kind of, did its job. It's still there, but I don't know if it's still running or not, which is, and I have friends at JPL that I keep sort of bothering to try and find out. But, the dust mitigation, like I said, maybe I only mentioned it very briefly, but there was an extra lining of a dust capsule. There was an extra filter put between where the diaphragm and the outer capsule was, and like a very thin little grill cloth, and that helped. The audio that we have shared and worked on has sounded great, at least with this microphone. The SuperCam microphone and architecture are very different, and so the sound and what we get back from that, or what's been recovered from that, is very different. And I can't speak to how dust might affect that mic, but this one had an extra layer of dust protection that seems to have functioned adequately as far as we've heard.
And then, have you composed any songs about Mars?
It's funny. Okay, so when it was weird. I kind of felt, even though yes, I'm a musician, but I felt because my role in this was sort of more like to make the technology happen and leave that to other musicians to do something with it. But the day it landed, I did a very quick analysis. So there's this motor whining sound that, as far as we could tell, was the thermal pump regulation system. And a quick analysis revealed that was, I can't remember, I think it was in the key of G, roughly. Like there was sort of a droning tone. So I put out just a quick thing online where I was playing the theme from 2001, Thus Spoke Zarathustra, I think it's called, the 2001 theme. But I played it in the key of G with that motor sound running in the background. So I did actually play over it in a melodic sense, but I've heard a few other people have put together some things, but I that's as far as I got with it personally.
Okay, we have about 1 minute left, but any plans to use multiple microphones, use stereo effects, echolocation on rovers, etc.?
So there's no specific plans on it now. It's something I've been pushing for years, actually. Back in 2018, I'd actually I'd authored a proposal at a Berlin planetary conference suggesting that we could operate the SuperCam microphone and the EDL microphone simultaneously. So, because in essence, we already have two microphones up there, and if they're still working, even though they are entirely different, the technical aspects of these mics are very different. They can, in fact, operate in stereo if you're able to operate them in that fashion. To my knowledge, that still hasn't been done yet, but like that sort of helmet design that I showed at the end, that would have 2 microphones on it. Yeah, absolutely. Stereo perception is we don't need to be doing 1950s AM technology. There's no reason we shouldn't be doing stereo, and I'm doing everything I can to help bring that about. Yeah, that would be. And actually, if I'm going to share, if I have a very brief moment, I'd like to share a link with everybody. You can check this out at your leisure. I want to put this in the chat. So there's a 16-minute recording sequence that was captured. This was on Sol 16, I think. So 16th Martian Day. That's right there. Click it. That was so that was audio captured with this microphone that we then ran through a couple. Oh shoot! I did not mean for that to actually start playing. Sorry. But it's you'll hear it. And I just sent it privately to somebody. Darn. Okay, sorry. Everyone. Okay, let me try this one more time. Okay, so there's a link for everybody. I encourage you to check this out. It's very, very cool. This microphone recording 16 minutes, and we cleaned. The only thing we did to clean this up, we didn't equalize it or fake it, except to use very specific noise reduction to pull out that pumping mechanism that I told you about, because it was kind of really whining and pervasive throughout, and we wanted you to be able to isolate and really hear how cool this sounds. So this is a microphone on Mars, and there's these reverberant things that bang around and clang, and that's the sound reverberating through the metal of the chassis itself. The creaking of the wheels and the ball bearings, or what we assume are the bearings of the wheel, are coming through the actual atmosphere. It's, I don't know, it's creepy or awesome, depending on, I guess what you're into, but you should check that out. It's in the chat.
Okay, cool. Thanks. Yeah, we're out of time for this session, but yeah, thanks again, Jason, for presenting.
Oh, it's my pleasure. I hope everybody enjoyed it, and thanks for having me.
Yeah, thanks.